Experimental results for asynchronous operation. Possible asynchrony between the two data streams reaching the encoding unit was also examined by introducing various sub-bit temporal delays at data B, as may potentially be introduced by mobile wireless users. A and B illustrates the input traces of OC data A and the delayed by 100 ps, 0.25 tau bit, data B, while C depicts the encoded XOR trace. Although short parasitic pulses of 0.25 bit duration appear at the encoded XOR stream, by implementing the decoding XOR function between the encoded XOR and the delayed data B, the trace of the decoded data A can be successfully retrieved, as shown in D. E. Shows that data B was also correctly decoded by the XOR operation between the encoded stream and data A, after a time delay of 0.25 bit duration. Experimental time traces Omicron F asynchronous 2.5 gigabits per second operation for two different time offsets. Time traces, 400 ps/div, for time offset equal to 0.25 tau bit, A, data A, B, data B delayed by 0.25 bit, C, encoded XOR signal, D, decoded data and, E, data B for time offset equal to 0.5 tau bit, F, data A, G, data B delayed by 0.5 bit, H, encoded XOR signal, I, decoded data A, J, data B magnified in sets highlight time offset. K, Burr curves of the decoded data signal for various time offsets between the input OC data. Similar results were obtained for the asynchronous encoding and decoding of NC operation where data B is delayed by a sub-bit time offset equal to 200 ps, 0.5 tau bit, as shown in F-J. F and G illustrates the SCM OC data A and B, respectively, reaching the encoding XOR gate with a time offset of 200 ps. H shows the encoded XOR trace exiting the first SOA MZI, while I and J shows the decoded data A and B after the second XOR operation between the encoded pattern and the initial data pattern of data B or A, respectively. In this operation, both data A and B were successfully retrieved, with decoded data B having a delay equal to the time offset. The highlighted insets magnify the traces in a specific part of the stream where the asynchrony can be observed and the XOR signal appears to have parasitic pulses equal to the respective time offsets. The successful asynchronous operation was also evaluated with Burr measurements, by inserting various relative delays between the two data and measuring the error rate for the down-converted decoded signal. K shows the Burr curves versus the average received power for time offsets equal to 0 tau bit, 0.1 tau bit, 0.25 tau by tan 0.5 tau bit, revealing error-free operation at 10-9 for all these cases. No additional power penalty when comparing the synchronous with the asynchronous operation was observed. This fact indicates that the performance of the proposed system remains functional even in the case of non-synchronized packets. The power penalty of the decoded stream with respect to the original down-converted OC SCM data is approximately 1.5 decibels.